Okay, here we are. Time for another lesson. We're going to be doing lesson number 5, MMU, Memory Management Unit. Seems like we've talked about this for a couple lessons. Well, I think we're just going to be the last one, and this is very important that everybody understands how this works and what you can use it for. It's the heart of the system. So, without further ado, let's take a look at, a little refresher from last lesson 4, where we talked about the text screen, the characters and the attributes, the character, when we brought that page in, it was page 36, we brought it in and we manipulated the screen instead of going through BASIC to do things. And we had some other statistics down here, an 80 character screen times 2 bytes for each one. A character attribute gives us 160 per line. 24 lines gives us all these numbers. And we ended up with 3,840 characters for a high-res 80 character screen, or $F00. And during that lesson I said, remember that number, we'll talk about it later. Well, now it's later. It's a whole 2 weeks later, but we're going to talk about it. And likewise down here, if you only have a 40 character screen, it uses half the amount, okay? Okay, and again, a refresher, our high-res text screen was in memory block 36. We swapped that in and we manually changed it from our program that was down in lower memory. Okay, here's what we did. Normally they were 38 through 3F, and we brought in 36. Our program was down here at E00, and we changed the stuff on the page. It displayed on the screen, and we swapped back out, or whatever. We didn't really swap it in. We just put our 39 back in there, and we refreshed it, and we was good as can be, and our program worked, and we actually changed without using BASIC. Okay, before we do that, let's take a look at some code. There we are. I hope I can find it on my other screen. Here we go. Okay, this is a code, and it looks almost exactly identical to what we did last time. All I did was copy lesson 4 over and called it lesson number 5. Okay, so we got, this one is 5A. We've got 3 programs we're going to do. Again, we're going to have to use the common include file. I'll put a new one out there because I added a couple items. It was 2 weeks ago. I don't remember what I added, but there was nothing major. I just added some few other things in there that I thought would be helpful. We have all of our palettes, our colors, etc. This all stuff is the same. And here we have another include file. Okay, it's common for lesson 5 only. Okay, we need that so programs can talk to one another. Okay, we'll get into more detail inside that file. This is the whole file is right there. Okay, not very much. It's got these 4 addresses, our print routines, and it's got our format of our object, which is common to everybody. Again, this program is the same as the last time. It loads at E00. We're going to print the same 7 help lines we printed last time. Load this X and branch subroutine print line. All this is the same. Our setup is the same. Our palette, swapping our page 36 in. Are into jobs, all the same, and here's our print line. Here's where it differs. We had all them routines, and if you did it last time, you can look at the code last time. This print line had all the stuff, okay, all that code in here about locating and printing, etc., etc. All the stuff it did was in there. Now we're going to do a jump subroutine to a routine called underscore print line. Okay, and it's got that's double underscore in front. Notice it's inside 2 brackets. If you remember what that means, back in an earlier lesson we did a jump subroutine to A000, which is basics get character. We waited for something on the keyboard. Okay, well that code really isn't A00. All that A00 had was the address where that code resides. So you just tell the system to jump subroutine to wherever's at A00, which is often Never Never Land. Same way here. Our code is somewhere, but this at, here, I'm going to move this over, at 2FF8, whatever's at 2FF8 is telling us where the code we want to execute resides. So we're going to get to more detail of this, so if I got you confused, that's good. So the rest of the program's the same. I think the only thing I did was I did fix that one underscore that was bad last time. I fixed that underscore. Other than that, this program's the same. Cut this stuff out of here and put it in another program. And without further ado, here's that other program. Let's call it less05x. Same common include file, it's all the same. Okay, we're including this lesson 5 one. That's why these programs can talk back forth to one another. And here's the program here, okay? We have, I'm going to take a break here and do one more back up and talk about one more thing here. Okay, I want to show what we're going to try to accomplish. This is our high-res page, X36. This is kind of what it layout is. It's not to scale, so we're going to bring in, like we did before, at 2000, between 2000 and 4000, or 3FFF. Okay, remember them numbers, that F00 I talked about, which is about approximately here. The whole, all the screen, 80 character screen or 40 character screen is located here up to this line for 80 characters, about halfway for 40 characters. All the rest of this from here up is open to use. The system never uses it for anything. Don't worry about these yellow blocks. We'll talk about them. We're going to take our code, our print line code and all them routines and bring it in here at 3000, right in this area here. There's another 256 bytes in here that's nothing's going to use it. We're going to use 8 bytes over here. So our code's going to end up in here. Okay, that's why I wanted to show you what we're trying to accomplish when we look at the code. Let's go back to the code. Okay, here's our code. We're going to load it at 3000. All right. Here is the code. Remember, I cut this out of the other program. Here is our print line routine, our locate print routines, our locate routine, the actual print the line routines. They're just an exact copy, absolutely no changes. And we're arguing them at 3000. So when it loads, it's going to load at 3000. Well, we've got this other 4, this is in the yellow box you see on another screen. Here's the 4 addresses so the programs will be able to talk to one another. We're putting out something in the one box that says where is print line. Okay, let's move this listing over. Print lines is at, oops, all the way over, is 3000. You can see that right there. We argued at 3000, so print line starts at 3000. And up here, this very first one, this FDB print line, when it compiles, it's at 3000. So our other program that we talked about, we said jump subroutine print line and use the code not at 3000 at this box here, but whatever in that storage bytes, and it had 3000. So when you do that, it's going to jump subroutine to here and do our print line. So we've got 4 routines down here. We've got print line, lock put, locate, and put line. So we've got 4 separate addresses up here for them 4 routines. So whenever you compile them, it puts the address of them in them 4 spots. Okay, so we get to load the program at 3000 and the addresses. We're going to try to get back to our other screen. That's them 4 boxes right there. I'm going to put them addresses right there. So the program's in lower memory, or any place in memory. All I have to do is look right there and it knows exactly where to go. Okay. Why are we doing all this? Well, you may want to think about, if you have, this is a pretty simple routine stuff we're doing now. But if you have multiple programs that you're going to use similar code, you want them to be able to talk to one another. So this way, that program doesn't have to know that we looked at 5A, doesn't have to know where any of this stuff resides. All it knows is has to know where these addresses are here, and the routines can go move any place. Likewise, in the future, we could come into this program here in the future and say, I want to add something to it. Right? I may want to come in here and say I want to do a push. For whatever reason, push that register, and before I go back, I may want to pull that register. Okay, that doesn't change this 3000, but we've added 2 bytes here, 2 bytes here. That's 4 bytes. So our next routine down here will be 4. This routine here would be 4. Wherever it was, 4 bytes down farther. This one will be down farther. And so if you had multiple programs that you hard coded into, it would know where to go. By doing it this way, no matter what you change up here, them programs will know exactly where to go. So let's look at another program we've got here we're going to look at today. This is called 05B. It's a duplicate of 5A. I mean, we're talking almost exactly the same. Same include files. There's the same 4 address, the same place. Here's the difference. Okay, this one, instead of being E00, is at 4400. So it's up higher in memory. Okay, same routine though. Print line, come back down here. Here's the print line. Find it wherever that's the addresses are telling us and execute. Now I have changed the messages down here so we'll be able to distinguish that they're different. But one other thing I'll show you while we're here, if you remember this locate, we also use in it in the jump subroutine. I did have to change this one here. We're at the end of our print routine. We wanted to move the cursor down to the bottom of the screen. Well, locate can find out where to go at 2FFC, and it will know how to get to its routine. So we got 2 programs, one at E00, one at 4400, and it should be hopefully good to go. We can switch screens again. Okay, this was our block. We're going to get up here at 3000. Okay, how do we do this? We got to get that program loaded in memory somewhere so we can use it. First step is load the code up at 3000. So here's a basic program. Look at what's in MMU register A1, which is 2000 to 3FFF. Save that, and then poke in our hex 36, our page we want to bring in. Then we're going to do a load in on our 5X program and restore that page back. And then it's sitting up in memory for us to use whenever we feel like it. Okay, see the note down there below? Sorry, that don't work. The coders of BASIC, we're going to back up a page here, okay? Ooh, went too far. Okay, remember our BASIC program, hope you can see the cursor here. Our BASIC program resides at 2600, right down here in the middle of block, when block 39 is normally, it's right in the middle there. So it will not let you swap anything in to FFA1. You'll get a syntax there if you try to do it in BASIC, because you'd be basically, I'm going to call it overlaying the BASIC program. It just won't let you do that. So we're going to have to somehow get that code in. What we're going to do is take our block 36 and bring it in up here at this 4000 to 5FF range and load it in. The coders of BASIC evidently run into this and coded it so it will work for you. Okay, so you can't use it, you'll get a syntax error. Try it. Just try doing a poke and it won't let you do it. Okay, because your BASIC program's there. We need to get it in at 4000 to 5000, then offset load it. If you look in your instruction manual under disk BASIC load in, it gives you an option to do it. So we're going to do the same thing here. Instead of doing it at FFA1. We're going to look at FFA2. We're going to poke our 36 in there to bring it in at 4,000. Then we're going to do a load M, and we're going to add this here to it. Offset it by 2,000. We're going to move, and this isn't changing our code. Our program does not change. Not one line of code changes in that program. It just, when you load it to a different address. Instead of loading it at 3,000, load it at 5,000 temporarily, because when we take that block out, we bring it back in, we're going to bring it back in where it will be at 3,000. Just, you have to think on that. All we're doing is just putting it in a different place temporarily. And back here, we're restoring our register. Okay, so you'll have to think through that, look at this a couple times and say, so you can understand it. Okay, so let's take a look at this and see what we've got. Okay, I've already loaded up that basic program. Okay, that's going to do that poke at A2 and do the offset load. So we'll run that. And that brought in our 36. It loaded the program with 3. Now it's sitting there in memory, okay? I mean, it's our basic program. It didn't hurt it. It's back where it was. Now we can bring in our other program. What was the name of that? Oops. All right, that was 5A. That was the one that's almost a copy. That was the first one that was a copy of last week's. Then we'll execute that. And there you go. It executed at E00. When it wanted to do print line, it branched up to 3,000 and printed the lines. Now let's bring in the other program that's up at 4,400. It's going to load up at 4,400. Okay, we'll execute it. And you see, we have different words in this one. This one here says this code's loaded at 4,400 and works using the code at 3,300. Wherever it said, just need to make sure that you got that other program loaded. Otherwise, you'll go off and never know. Confused? Go back, review lessons 3 and 4, and come forward again. Okay. So our basic program is still there. I can execute the one at E00. It's still there. And the 4,400 one, it's still there. Okay, so I hope to get some memory juices flow and say, oh, okay, I think I might understand that. If not, go back, review, retype the stuff in, and come forward. Because you got to think of what that means by being able to use that stuff. I call it stuff. I mean, it's not probably the best language in the world, but that's what it is, stuff. Let's finish this up. Okay, thoughts on using. Okay, while we're talking here, I'm going to, you may hear this in the background, I'm rebooting my machine. Things you can use it for. Okay, I use it for pop-up windows. I have pop-up windows on my machine that I use all the time. And I'll demonstrate that here in a second. Come on, baby, you can reboot. Okay, back to what we're doing. Okay, I have common routines. Well, all of my pop-up window codes, believe it or not, is up there at 3,000 and so. So all the pop-up windows, I got pop-ups and pop-ins in there, which are some difference in there, that uses all that memory that we just used. So I overlaid it when I loaded it here for this test. And I also use memory block 14 to have a copy of the screen. I have a lot of common routines out in block 9, string functions, math functions. Then I can do jump subroutines. So I have a lot more than that. That's just an example too. I also have the menus for all the pop-ups. It shares this common routine page, okay? And on block 17, or hex 11, the last 75 commands I typed in, I can recall them just by hitting the F1 key. Okay. There's a lot more stuff out there. Just give you some idea of things that you possibly can do. If I can bring back in that, if I can get to it, okay. Okay, I'm going to hit the F2 key. Okay, here's my pop-up windows. Okay, and I got all sorts of stuff out there. You can read them. I want to do some help on stuff I don't remember what it is. and brings up or pop in, okay? If I want to look at some math functions, I can hit 1, okay? All right, if I want to do multiply B times by Y registers, I can hit a 3. And it gives me an idea what I need to do instead of digging out some kind of code to remember what it is. And that tells me exactly what I need to do to input what registers and what happens to it. Okay. If I hit again, it'll pop up. If I want to change the palettes, I can hit 5. Don't want to reset back to standard or modify. I'll say reset back to normal. Okay. It changed it to what that's way of, if you boot the machines, what it would be. And I can go back in and run in a modified version, which I have. I can change the colors. Change the background color to 3. Anyway, so much for that. That's all the internet page sitting out there all the time. It's always available. All I do is hit a button. Okay, so think. And one more quickie here. As we've doing everything with text. Text is easy because it's immediate result. We don't have to worry about coding for sprites and offset and bits and all the graphic screens. We're doing the text stuff we've been doing. It's simple. You get quick and easy results. You can change something and look at it immediately. It's kind of simple, and that's why we've been doing it. It works the same way if you're in a graphic screen or in a text screen. So if you're going to be doing graphics, things you could use it for, some possibilities, some extra coding routines. Like if you have some routines that are like beginning of job routines, end of job routines, and you need memory for your graphic stuff. It could be out there. Keeping scores could be kept out there off in another page. Extra copy of your screen, you're probably going to need that if you're going to be doing graphics. You have multiple copies of it. And you can have lots and lots of sprites loaded out in these pages that just sit out there to use them whenever you feel like it. Many other things that I haven't even thought of yet. So hopefully this helps. Remember, if you got any confusion, go back and look at lessons 1, 2, 3, and 4. Come back forward, and hopefully you're getting it now. So I think we're going to be done with this one here, and hopefully, I don't want to say hopefully, but I'll figure it out in the next couple weeks. We'll do some graphic stuff. We'll move over off of the text screens and actually do something with graphics. So until then, get caught up. And I'll put some of this code out there again as usual, but it's better if you try to type it in yourself, change the messages. In fact, I'm just going to put screen 5A and X out there. You'll have to do B all on your own, put whatever you want into it. So anyway, hopefully this isn't too long. Later.